All right, so we are going to start off with sun's altitude and seasons, and we're actually going to go to question number 2. And so question number 2 states, in the diagram below, a vertical post casts shadows A, B, C, and D at 4 different times during the day. Which shadow was cast when when this location was receiving the greatest intensity of insolation? All right. So when we're talking about the greatest intensity of insolation, all right, we're talking about a moment when we have the greatest amount of energy that comes from the sun, right? High energy, greatest amount of energy that comes from the sun. All right. So we're looking for a time period where we're getting the most amount of energy. All right, I know high energy, the most energy that comes from the sun. And so the rule is that in order to get the most energy that comes from the sun, the rule is to get the greatest intensity of insolation. That means that we have to pick a point where we have the highest altitude, the highest altitude of the sun. Okay. It has to be a point where we get the highest altitude from the sun. Okay. So keep that in mind. So what do I know? How can I tell which shadow cast when the sun is at its highest altitude? How can I tell? Well, when we go to our notes, right? And from our notes, one of the things that we saw right here is that the higher the angle, the shorter the shadow. So if we're looking for where the sun has the highest angle, we're looking for the shortest shadow. And so therefore, when I'm taking a look, out of all 4 of these, which one has the shortest shadow? That's right, everybody. It is choice C, right? Because the angle is so short, that lets me know that the sun's altitude is the highest. Is the highest. And so that's something you have to keep in mind. The greatest intensity of insolation is going to be when the sun's altitude is the highest. And when the sun's altitude is the highest, you're going to get the shortest shadow. That's why it's choice C. All right, number 3. It says the diagram below shows the apparent path of the sun for an observer in New York State. Okay. It says for this, so this path right here is representing of the sun. For this observer, the intensity of insolation is least. All right, I want to make sure to highlight that. Is least when the sun is at point what? All right. We just said in the previous problem, the intensity of insolation, it depends on the altitude of the sun. Altitude of the sun. All right. You're going to get, so the higher the sun is, the higher the altitude of the sun is, the higher the intensity of insolation. So if we're looking for when the intensity of insolation is the least, that means it has to be at a location when the sun's altitude is the lowest. The sun's altitude is low. All right. So which letter gives me where the sun's altitude is the lowest? And it's going to be point D. All right. When the sun's altitude is low, the intensity of the insolation is very small. So that's something to keep in mind, right? Once again, the intensity of insolation has a direct relationship with the altitude of the sun. All right, number 5. So number 5 says, base the answer to the following question on the latitude and longitude system shown below. The map represents a part of the Earth's surface and its latitude, longitude coordinates. Points A through F represents the locations in this area. All right, let me zoom in more. So it says, which location would have the greatest angle of insolation on June 21st? All right. So I'm looking at June 21st, and one of the things that pop up when I see this date, June 21st, I immediately think summer solstice, right? I immediately think summer solstice. That is the date of the summer solstice. Okay. Now it says which location would have the greatest angle of insolation. So that means which location would receive the highest angle of the sun. That is what this question is asking. The greatest angle of insolation, where is the sun at its highest point, right? Where's the sun at its highest point? Which latitude will it be? Well, when I go to my season notes, there's something very special about the summer solstice. All right. And what do I know about the summer solstice? If you take a look right here, it tells us, right, that during the summer solstice, the sun is directly over your head at a 90-degree angle at what latitude? 23.5 degrees north. This latitude is also known as the Tropic of Cancer. All right. So that lets me know that if I'm at 23.5 degrees north, I know for a fact during the summer solstice that the sun will be at the highest angle at noon. When I go back, this is the question that you have to ask yourself. Which one of these points is closest to the Tropic of Cancer, right? We just said that 23.5 degrees north, the sun is going to be 90 degrees directly over your head. 23.5 degrees north kind of looks somewhere around here, right? So the question is, which letter is closest? Which letter is closest to 23.5 degrees north? Because we said at this latitude on June 21st, the sun is going to be at a 90-degree angle above an observer's head, all right, at noon. So I need to pick a location that is closest to this latitude. Which letter is closest to 23.5 degrees north? And it is letter F. And the correct answer is choice F. All right, number 7. We're going to take a look at number 7. So number 7 says, in the middle's latitude of the southern hemisphere, the warmest month is usually what, right? So when we look at our Earth, and we know that our Earth is split up, right? The northern hemisphere is above the equator, right? So the northern hemisphere is above the equator. The northern hemisphere is above the equator, and the southern hemisphere is below the equator. Okay. What else do we know about, let's say, in regards to seasons of the northern and southern hemisphere? Well, I know when one season's in the northern hemisphere, it is the complete opposite in the southern hemisphere. Okay. As a matter of fact, I'll just show you very quickly. I'll show you a diagram that we have here. There we go. All right. So when you're looking at this diagram, you could already see, right? When it's summer in the north, it's winter in the south. When it's winter in the north, it's summer in the south. The north and south are referring to areas above and below the equator, right? When it's spring in the north, it's fall in the south. When it's fall in the north, spring in the south. So when I'm looking at this, what do I know? That the seasons are opposite. Whatever season it is in the northern hemisphere, it is the opposite season in the southern hemisphere. All right. Why does this matter? There we go. This matters because I have to think opposite, right? If I'm in the northern hemisphere, my hottest month in the northern hemisphere, my hottest months are going to be in the summer, right? June, July, and August. However, right, in the southern hemisphere, in June, July, and August, in the southern hemisphere, it is winter in the southern hemisphere. So that means I got to ask myself, when it is cold in the northern hemisphere, it is warm in the southern hemisphere. So what months in the northern hemisphere are cold? Right is where winter is. In the northern hemisphere is winter, where we have December, January, and February. All right. Now, in the southern hemisphere, when it's winter, the northern hemisphere, it is summer in the southern hemisphere during these dates. So, the warmest month is going to be during the winter time in the southern hemisphere. And what month is during the winter time? February. So the one thing to keep in mind is that the seasons are opposite when you're in the northern hemisphere compared to the southern hemisphere. All right, number 9. Number 9 says the diagrams below represent Earth's tilt on its axis on 4 different dates. The shaded portion represents the nighttime side of the Earth. Which diagram best represents the day on which the longest duration of insolation occurs in New York State? So this is all occurring in New York State. The problem is focusing on New York State. Which diagram best represents the day on which the longest duration of insolation? So duration of insolation, you know what that means? That means the amount of, let me make it thicker. Duration of insolation means the amount of daylight hours. The amount of daylight hours. Okay. So next, the amount of daylight hours that occurs in New York State. The longest duration of insolation is they're going to be talking about the longest amount of daylight hours then. So if I'm in New York State, the longest amount of daylight hours I get is during the first day of summer. Is during the first day of summer. Okay? So during the first day of summer, when I'm taking a look, first day of summer, what do I know? I know that my sun, wherever that my sun is, the North Pole has to be tilted towards the sun, because the longest duration of insolation, it occurs during the summer solstice for New York. So basically, I'm asking myself, which diagram represents the summer solstice? And it has to be the diagram. It has to be the diagram where the North Pole is tilting towards the sun. The bright part tells me where the sun is going to be. So the fact that the North Pole is lit up, that lets me know that's tilting towards the sun. And that's why it's going to be choice 2. Right? That represents the summer solstice. All right, so number 11 says the model below represents the apparent path of the sun across the sky on March 21st, as seen by an observer on Earth. At which latitude is the observer located? All right. So one of the key things, when you see a diagram like this, there's two things that I would say for you to pay attention. Pay attention where the sun rises, right? Where the sun rises. And we always know the sunrise is always going to occur somewhere on the eastern side, right? It's going to occur always somewhere on the eastern side. And in this case, it rises directly east. All right. So in this case, it rises directly east and sets directly west. The key thing when you see a diagram like this, especially when they're asking what latitude is the observer, not only do you notice where the sun rises, okay, you also want to see the date. So this date, March 21st, it lets me know that this is an equinox date, right? March 21st is an equinox date. And what's interesting about this is that the observer, the sun is directly above the head of the observer at noon, right? It is a clear 90-degree angle at noon, all right? So I'm going to look, when I look back at my notes, what I learned about an equinox, they tell me during the equinox, and it tells me right here, let me change the color. They tell me right here, during the equinox, the sun's rays form a 90-degree angle at noon. Where? At the equator. So it forms a 90-degree angle. It forms a 90-degree angle at the equator at noon. And that lets me know that, well, if the observer, if the sun is directly above the observer's head at noon, and it occurs on March 21st during the equinox, that lets me know that the answer is choice 4, at the equator. All right, number 12. Number 12 says the diagram below represents the apparent path of the sun as seen by an observer on June 21st at a location in New York State. And so the question says, which diagram best represents the path of the sun at the same location on December 21st? All right. Well, we know, first of all, we know that this person is in New York State, right? And we know where the sun rises on December 21st, which is also known as the winter solstice. Sorry. Winter solstice. All right. So when I look at my notes, one of the key things that stands out to me is that during the winter solstice, I see right here, the sun rises southeast and sets southwest during the winter solstice, December 21st. So when I'm drawing my diagram, if you remember in class, right, it starts southeast, right? My highest point of my sun's path has to hit the south side, right? And then it sets southwest, which is right here. The other thing that I do know from my winter solstice sun's path is the fact that the sun's path has to be higher at June 21st. then December 21st. Right? So because it's December 21st, I know that I need a lower path. Okay? And remember, the sun rises southeast and sets southwest. So which diagram looks very similar to what I just drew up here? Which diagram? And remember, the key thing is where it's starting. I'm starting between south and east, right here. And I'm ending between south and west, right here. So when I take a look, the one that shows that is choice 3. Is choice 3. Now it would have been choice 4, right? It would have been choice 4, but only if, oops, sorry. Hold on. Actually, no, it wouldn't. Yes, it would have been choice 4 only if the location was at the equator. But because of the fact that they tell me it's New York State, right? That's why my sun's path has to be tilted to an angle. That's why it's choice 3. It would have been choice 4 if it was the equator. Then it would have been choice 4 if the location was the equator. But because it's New York State, that's why the correct answer is choice 3. All right, number 13. So number 13 says, base your answers to question 13 and 15 on the diagram below and on your knowledge of earth science. The diagram represents the apparent path of the sun as observed at 4 locations, A through D, on Earth's surface on the same date. So keep in mind, on the same date. The zenith, the position directly overhead, is shown for an observer at each location. Diagrams are not drawn to scale. And the question says, what is the approximate time of day represented at each location? Okay. So in order to find out the time of day it is, we have to look at where the sun is. We have to look at where the sun is. And this is all occurring on the same day. All right. So one thing that's very interesting to me, right? Even if you weren't sure about what's going on here, all right, even if you weren't sure that what's going on here, even though this is a representation of the North Pole, right? This is a representation of the North Pole. But if we focus that location A, B, and C, I see that the sun rises directly east on all 3 of these. And so that lets me know this must be the equinox date. You know what else that this lets me know? Because this is the equinox date, I know that the sun's path is 12 hours long because there's 12 hours of daylight. All right. The other thing that's interesting, even if I focus on locations A, B, and C, is that at this point right here, where the line reaches its highest point, these are all representations of solar noon, 12 p.m., 12 p.m., all right? Even right here represents 12 p.m., okay? And so therefore, if this point right here, right, represents 12 p.m., let me erase, sorry. If this point right here represents 12 p.m., this point right here represents 12 p.m., this point represents 12, this point represents 12, and now the sun is on the setting, right? It's on the opposite part, right? On this side, the west side, that means that it's on its way down now. I know that my time has to be after 12 p.m. it has to be after 12 p.m. So automatically, when I'm looking, automatically, I can definitely cross out 6 a.m. There we go. I can definitely cross out 6 a.m. and 9 a.m. At 6 p.m., I know that the sun should be setting during the equinox date. At around 6 p.m. during the equinox date, the sun should be setting, right? So the fact that it is not at sunset yet means that it cannot be choice 4. And so the best answer is choice 3. All right, the best answer is choice 3. All right, and it makes sense. If 12 p.m. is here, if 12 p.m. is here, then to the right should be after 12 p.m. And 6 p.m. is right at sunset. So therefore, 3 p.m. would be somewhere in between. That's why it's choice. Sorry, choice 3. All right, number 14. It says during the course of the day, which location had the greatest intensity of insolation at solar noon? So at solar noon is when the sun is at its highest point. Highest when the sun is the sun's highest altitude. All right. At solar noon is the sun's highest altitude. So solar noon is right here at location A. It's up here at location B. It's right here at location C is right here at location B. And it's right here at location D. The red circles all indicate where solar noon is. Okay. Now, the one that has the highest angle at solar noon, right? The greatest intensity of insolation. If you want the greatest amount of insolation, it has to be at a point where it's the sun's highest altitude too. All right. So the greatest intensity of insolation has to be when the sun's at its highest altitude as well. And which location is where the sun is at its highest altitude at solar noon, right? Where the red dots are? It is location C. So the correct answer is choice 3. Basic answers to questions 16 through 18 on the diagram below and on your knowledge of earth science. The diagram represents the apparent path of the sun across the sky at a New York State location. That is important. It's at New York State. On June 21st, that is another important thing. It's on June 21st. Point A represents the position of the noon sun. Points A and B on the path of 45 degrees apart from each other. All right. This is also important too. All right. So number 16, it says, compared to sun's apparent path on June 21st, the sun's apparent path on December 21st at this location would be 1. So if this path is June 21st, right, then you know December 21st, if this is north and this is south, December 21st is going to have a path like this. Okay, this would be for December 21st. How do I know that? Well, not only the fact that I know that the sun rises on the southeast and sets southwest, but you have to know on December 21st, the sun's altitude is lower. Is lower. And if the sun's altitude is lower, then that means the path is going to be shorter and the noon sun will be lower in the sky. That's why the correct answer is choice 1. All right, number 17, it says, Which diagram represents the correct position of Polaris as viewed from this New York State location on a clear night? So which one represents the correct position of Polaris as viewed from this New York State location on a clear night? So first of all, I know this is New York State. Why does that play a role? Because my general latitude for New York State is going to be somewhere in the 40s, right? It could be anywhere from like 44 degrees north all the way to, let's say, like 44 degrees north. All right, that's the first thing. The second thing that's interesting, right? Polaris is always going to be seen. Polaris is going to be seen somewhere. Polaris is never seen towards the south side, right? So that lets me know it's definitely not going to be one. Why? Because it's showing Polaris to be located on the south side. So it cannot be that. All right, it cannot be that. Let me change the color. There we go. Yep. Polaris is located on the south side for question 1, and that is incorrect. Polaris will never be located towards the south side. All right. The second thing, because New York State has a latitude somewhere between 40 degrees north to 44 degrees north, that means that my altitude of Polaris is also going to be somewhere between 40 degrees to 44 degrees, right? So it can't be choice 4 because the angle is 0 here. Let me change the color. It can't be choice 4 because the angle, there we go. The angle is 0 here. All right. It can't be choice 2 because the angle of Polaris at this point is 90. However, the angle for 43, it looks kind of like 45 degrees, right? So my best answer, it has to match up between 40 to 44 degrees, right? So my closest answer is definitely going to be choice 3. And lastly, number 20. Number 20. So it says, base your answers to the following question on the diagram below and on your knowledge of Earth science. The diagram represents Earth's position in its orbits on the first day of each of the 4 seasons, one of which is labeled A. The North Pole is labeled N. Earth's closest distance to the sun and Earth's farthest distance from the sun are labeled in kilometers. So it says, what would happen to New York State's summer and winter temperatures if the tilt of the Earth's axis increased from 20.5 degrees to 30 degrees, all right? If the tilt of the Earth's axis increased, right? So if the tilt of Earth's axis increased, if it increased, then that means you would have more extreme seasons. You have more extreme seasons. What does that mean if you're extreme seasons? That means that if summer is identified, right? Summer is identified as pretty much like a hot season. That means an extreme summer is going to be hotter, right? And so if winter is identified as a cool season, then that means that with an extreme winter, it means it's going to be cooler. And the one that shows that is choice 4. If the Earth's tilt were to increase, your seasons would be more extreme, right? So summers will be warmer and winters would be cooler. All right. That is pretty much it. I almost want to show as a bonus round, right? Just for number 18. Okay. Where it says how many hours would it take for the apparent position of the sun to change from point A to point B? The key thing they tell you is right here. Point A and B are 45 degrees apart. You also know that point A is at its highest point, which means that it's 12 p.m. So you know point A is 12 p.m., and you know that they're 45 degrees apart. The question becomes, what is the rate that the sun appears to travel as it moves across the sky? Because the Earth rotates at 15 degrees per hour, the sun also appears to move at 15 degrees per hour as well. So we got to ask ourselves, how many hours have passed by in 45 degrees? If we're moving at a rate of 15 degrees per hour, then that means that in 45 degrees, it traveled 3 hours. What's 3 hours past 12 p.m.? 3 p.m., right? But the question only asked how many hours did it travel? And we got the answer right here. How many hours would it take for the sun's position to go from point A to point B? It's 3 hours because the rate is 15 degrees per hour. All right? That's why it's 3 hours for 18. All right. Have a wonderful, blessed day, everybody, and I'll see you till next time.